Okay guys, so what we are going to be doing today is the Alka-Seltzer Lab. So we're going to start off, I have a starting sentence statement for you for our hypothesis. If I put effervescence tablets in water that is 19 degrees Celsius, 5 degrees Celsius, and 80 degrees Celsius. Then the tablet in the water that is 80 degrees Celsius will dissolve faster because, now what I would like is you to come up with your because statement for your hypothesis. Go ahead and pause the video so you can go ahead and write that out. Then we're going to move on to the procedures. So now we've moved on to our procedures. When doing this, normally we would have a designated person for each one of these experiments, but since you are just watching the video, you don't need to worry about the recorder, the timer, the material gatherer, and the experimenter. So what we're going to skip over is we are going to go down to number 2. So get your lab kit from your teacher, which is already going to be in front of you. Each kit contains 1 goggles for each member and 1 graduated cylinder, 1 paper towel, and 1 timer. And it will also contain a silicone holding pot so that when you hold the warm water, you will not burn yourself. And moving on to step number 3, your teacher will provide each of the 3 temperatures, which we already did at the beginning of the class. We have all 3 of the temperatures up in our hypothesis. So what we are going to do is record our data below. So you are going to get 60 milliliters of room temperature water and 1 Alka-Seltzer tablet from your teacher. You are also going to get, or remove it from the package and move on, and we're going to test it out for the first one. So we have our room temperature. I need 60 milliliters of water, so I'm going to fill it up to 60 milliliters of water right now at room temperature. Okay, so I have 60 milliliters of room temperature water. I am going to drop in one of the tablets to find out how long it's going to take for it to dissolve in the water. Oops, this one broke up a little bit. It's okay though, because I can still use it, because it's still the same amount of matter. So I'm going to drop it in and I'm going to start the timer. Can you start the timer? You ready? As you can see, the chemical reaction is happening in there. You can see the temperature causing, or you can see the water bubbling up and getting all fizzy. We're going to sit and wait until we see all of the bubbles gone. Still going a little bit longer. Looks like the tablet is completely gone. I would say go ahead and stop. So the time it took for that one to completely dissolve was 1 minute 26 seconds. Dang it. Got white up. 86 seconds. did you start? Okay, so I did make a mistake. I did say it in minutes and seconds, so it needs to be in seconds. If we add 60 seconds to 26, it'll get 86 seconds is how long it took for us to have this dissolve. So the next one we are going to move on and do is the cold water tablet. So for this experiment, we're going to do the same thing as we did for the previous one. I'm gonna get 60 milliliters of cold water, and then we are going to test it out. Right there? No. Oh. Perfect. There we go. So I have 60 milliliters of cold water. The next thing we're going to do is drop this one in and see how long it takes for us to have this one dissolve in the cold water. Remember, this is 5 degrees Celsius. And go. You can already tell that the bubbling is a little bit different. It's not as fizzy as the last one. Okay guys, I'm going to take a pause because this one's going to take a while. So we're going to pause this for right now and we'll be right back in a second. Okay guys, and we're back, and it looks like it is almost completely dissolved based on what we had before, and we're coming up on the 3 minutes and 25 second mark. So I would go ahead and stop that, and if we have to calculate that into into seconds, we need to take how many seconds are in a minute. There is 60 seconds in a minute, so 60 times 3 gives us 180 seconds, but we also need to add that extra 26 seconds to it, so 180 plus 26 is going to give us 206 seconds is how long it took for it to dissolve in the cold water. And now we are ready to move on to our hot water test. So we have our hot water here at 80 degrees Celsius. I'm going to pour it in and have 60 milliliters of the warm water. You can already see the steam coming off of it right now. Okay, so I already have it in the graduated cylinder, and this one's going to go pretty quick. And go. Ooh, splashed a little bit. Oh, almost there. So much faster than the other two. And we're done. So guys, that one took all of 18 seconds for it to dissolve in the hot water. So the next thing we're going to do is we're going to pause the video for a little bit, and we're going to go ahead and go through and do some tests to get some group data that we were going to collect for all of you guys. Okay guys, so we're back. The first thing we are going to do, if you look down at the directions, you recorded the group data. So we went through and got the group data for a couple of the experiments. And now we are going to go through and average out the class's data. So we're going to go through and take an average of all of our information. Now, how do I get the average again, you might ask? Well, it's pretty simple. We're going to take it step by step right now and do it together as a group. So we're going to do the room temperature, which was 19 degrees Celsius first. So we're going to add 86 plus 90 plus 93 plus 82 plus 84 and plus 91, and we get that total. The next thing we are going to do to find the average, we are going to divide it by how many groups went into this, and how many groups did we have go in? We had 6, so we're going to take 526 divided by 6, and our average for this room temperature was 87.6.
7.
Oh, sorry, 0.7. I couldn't read it upside down.
And now you can take this and you should be able to now calculate the other two on your own. Go ahead and pause the video and do that right now.
Okay guys, so now that we have the average times that it took for each trial, we're gonna go through and create a bar graph, which a bar graph is when we have different substances and we compare them to each other. So what we are going to do is we are going to make the temperature versus the time graph over here. So our x-axis is going to be the temperature to see each one of the different categories. Right now I already have it grouped as 19 degrees Celsius, 5 degrees Celsius, and then 80 degrees Celsius. And along the y-axis, I have already marked on here the time to dissolve. So what we did is we made it so it went by 20 seconds as we went up. So 20, 40, 60, 80, 100, and so on for the amount of time that it takes for each one of these tablets to dissolve. So the first thing we're going to do is I'm going to show you how to do the bar graph for number 19. We got an average total of 87.7. So we're going to come on over and we see the 80s right here to 100. So we need to somehow figure out where would it be at about. It's almost to the 90. So I would say it's almost about halfway up to 100 for our average. And that whole bar, I would shade down or draw lines to symbolize that that is where the bar graph goes for the average temperature for the room. Now I'm giving you guys the chance to go ahead and draw the other ones that you just calculated the average for, and you'll be able to compare the data to each other. Once you have finished doing all of those things, then you are going to move on down and do the conclusion questions and answer them based on the information that you collected.
Also, please don't forget, it asks you to give the graph a title and to label your X and Y axis, so make sure that you do that step as well, and don't forget to make sure that's completed. Please also note that we had to add an extra row at the top. That's because on our data table, the cold water was such a long temperature that it was more than 200 seconds. We had to add an extra row for that, which is perfectly fine. Please make sure your lab is completed and then make sure you submit it as soon as you are done.